Okay, today we are starting with a review of yesterday, and hopefully, I had already given the kids this for a few minutes. They have factored the top. Did you factor the top into x plus and x plus? No, that's impossible, because it's a negative 8x in the middle, and therefore it has to be x minus and x minus. And two negatives will make a positive 9. So then it must be a 1 and a 9 or a 3 and a 3. But a 1 and a 9 would make 9, but it's not making my positive 8x that I wanted in the middle. So bottom line is this thing won't factor, really. Okay, yes. But what I'm trying to say is, will this thing factor or not? Okay, won't factor. All right. So does that really matter? If it had factored, do you get why I needed to know if it factored? Because what if there'd been like an x minus 3 in this? If this had factored and had an x minus 3 in it, we'd have known there was a hole. But do you get, since it didn't factor on the top, then nothing can cancel like that, and therefore there is no hole? That's why even if it can't factor, that's valuable information. So if it can factor, that helps. If it can't factor, that helps too. All right, next thing is domain. Domain is all real numbers, and I like to start with a number line that everything's shaded, and then say what won't work. What won't work is -1 and +3. And so I make empty spots there. And now there's my domain. Everything works except -1 and 3. And those are the two things that would crash it. Now those two things are either holes or asymptotes. And since we determined there was nothing that's going to cancel, therefore they can't be holes. Therefore, they're both asymptotes. Which kind are they there? Yes? Vertical. And therefore, it's x equals -1 and x equals 3. If you just said -1 and 3 without the x equals, you aren't telling me which asymptote they are, and therefore it's wrong. You have to have x equals -1 and x equals 3. And the last is the horizontals. And who tells you about the horizontals? Bob. Is this a Bob? No, it's a sob. It's the same on both, and therefore it's a ratio of the lead coefficients, 1 and the 3. Therefore, y equals 1/3. Notice I have to say y equals, because that tells me which way it goes. It's horizontal. It goes like the horizon. All right, now the new thing for today would be, how could you draw this without a calculator? All right, so first step is you actually make those asymptotes. X equals -1 would be like here. X equals 3 is like over here. And y equals 1/3 is like going right here, wherever 1/3 is. Okay, and now I know that there's going to be stuff in every little area. I shouldn't say it that way. There should be stuff in between here and here. And then there's stuff to the left of the red line and stuff to the right of the red line. So there's, in this zone there's something, in this zone there's something, in that zone there's something. So how do you tell where? This is the new lesson now. Number one thing is asymptotes are number 1. That's how you start. And intercepts are number 2. What kind of intercepts are there? Well, there's x-intercepts and y-intercepts. Okay? The y-intercept is where x is 0, and that's a particularly easy one to do, because I can stick in a 0, and a 0, and a 0, and a 0, and I can figure out where the y-intercept is. It's at 9 over, you get that that's really 3 times 1 times -3, which is -9. 9 over -9 makes -1. So the y-intercept is at -1. That helps. Now, does it completely tell me where this thing is going? Nope. Well, my theory is that it's going to do something like this. But how am I going to know for sure? You need to find more than just the y-intercept. You need to find a few points. Just find a few points that are in there. Because if I knew that this point, and this point are on there, I'm going to be like, okay, I can for sure see where this thing is going. So I need a few points. Well, sticking in x is 0 is the easiest one, because a lot of things cancel. Scary. Then putting in x equals 1 is another easy one. Let's just do that one quick in your head. 1 squared minus 8 plus 9. All right, so if I test this point, which is 1, I hate to say it, but I'm telling you a point to test that isn't super helpful. It'll be a little helpful, but it's not super helpful. I'll show you where the really good ones are in just a second. All right, so if I test that x is 1, did you get 1 minus 8, which makes negative 7, plus 9, which makes 2? Right? 2 over, and then 1 plus 1 is 2, times 3 is 6, times negative 2 makes negative 12, and that reduces to negative 1/12. Do you get that? That's a small negative number? What? 1/6, sorry. 1/6. Negative 1/6. All right, the fact that it's negative helps me. It was headed that way. At least I know it's headed that way. All right, but what's really important is, do you get that this, they have to head towards the asymptotes. In the end, it has to either be going, for instance, like up here, or it has to be going down there. Because it has to be, in the end, getting closer and closer to the intercepts, or to the asymptotes. So it either must be really high eventually, or really low eventually. Therefore, we need to test something really close to the asymptote. Those points are what's going to help us the most. So I know these 2 points are on it, but the better points are, if I knew that this goes really high up there, then I would know the ending to the story. It must be like this. If I knew that the one really close to the asymptote was really low, I'd know it must be heading down like this. All right. So where is the asymptote, first of all? The asymptote's at 3. I know this is going to seem weird, but we don't even want to just test 2. We don't want to test 3 because 3 will fail. 2.9. Now, I know you don't want to put in 2.9 because the numbers are going to be ugly, but the point is, do you get that if I say 2.9, it should get either a really big positive number or a really big negative number? Because I'm so close to the asymptote. It must by then tell me where it's going to go. So I should test on either side of this 3. I should test it and see where it ended up. So I'm going to test at 2.9, and I'm going to see what happens. 2.9 squared is about 3 squared, right? So 3 squared is about 9. Minus, what's negative 8 times 2.9? Notice me saying it's about 3, okay? We're going to have to adjust for that later, but 8 times about 3 is about negative 24. And then the plus 9. So then that's 18 and negative 24. Do you get, I'm off a little bit because I was rounding, but it's going to be okay in the end. I end up with 9 and 9 is 18, and a negative 24 is negative 6 about. Okay, we didn't need to know exactly where this point is. That's a ballpark on the top. Now on the bottom. Do you get why we can't exactly use 3 here? Because as soon as we put a 3 there, it's going to become 0, right? So we do need to use 2.9 there, but we're just getting an approximate anyway. About 2.9, about 2.9. Okay, so this is about 3.9, which is about 4, really. Times 3 is about 12. Times, that's where the real interesting part is. I now have 12 times negative tiny number, like negative 0.1. 12 times negative 0.1 makes negative, that's important, 1.2. Bottom line, do you get, I have a negative divided by a negative, which means I have a positive. And therefore, even if it isn't very big, if it's positive, it's above this line, and therefore it must be heading that way. Now, it's possible that when I put it in to this one that's really close to here, maybe I'll find out it's heading up on that side too, but I don't think so. So I'm going to test and find out. All right. I'm going to test at, well, this was negative 1, so I'm going to use about negative 0.9. Because this was negative 1. I'm going to check just on this side of it and see what negative 0.9 would do for me. It's a little tedious. And do you get negative 0.9 is about negative 1? Do you get that we're going to do that all the time? Okay, so negative 1 squared is 1. And negative 0.9 is about negative 1. The reason we have to keep saying negative 0.9 because we can't really put in negative 1. because it'll crash it. Negative 0.9. All right, so this is about negative 1, which makes positive 16. All right, so we have a 1 plus a 16 plus a 9. So 17 plus 9 is 26. A big number divided by... Not 16. Sorry, you're right. 8. 8 and 9 makes 18. Sorry. Whew. But do you get the sense that we're really just trying to get a ballpark idea? It's a big positive number is the main thing I really care about on the top. I know you guys are, some of you are like perfectionists where you want to know exactly what's the exact right answer. This is one of those times that might annoy you, but we don't really care. We were trying to get an idea of, is this going to be a big positive number and therefore go up on this side, or is it going to be a big negative number and go down on this side? How far off I am really doesn't matter. I mean, I made a mistake in there, you're right, but I hope you get that we don't care exactly what this is, other than it's a big positive number. And down here, when we put in about negative 1 here, that makes this about negative 4 times, is this positive or negative? Positive, so we have negative 4 and a positive small number like positive 0.1 and then a positive 3. That makes negative 12, and then you're multiplying it by 0.1 is negative 1.2. Do you get it is a big negative number? All right, so then I now know that my graph goes like up here through these points and down there. All right, and once I found out that I test just on the other side of 3, like 3.1, I'd find out it was way up here. And I'd be like, oh, I know how this goes. And then once I test just on the other side of this, I'd find out it's a big negative number. And that's how you sketch these rational function graphs. You got to know how to find their asymptotes. You got to know whether there's holes in them or not. But when it's all over with, you're going to have this thing that's got a couple asymptotes and maybe an asymptote going this way. And you got to be able to test and figure out just on each side of the asymptotes. So I think this one might look like this. But I'd have to test a few spots to make sure that it does. Because maybe the middle part goes like this. I don't know. And the other thing that can happen in the middle, sometimes people don't see this coming, is it'll do this. That's why you got to test on both sides of the asymptotes. All right, so let's do number 2 and make sure that you're understanding how to make the asymptote parts. Everybody figure those out. Domain, verticals, horizontals, and if there's any holes. How many of you are already done with that? 3 people, okay. I'll pause for a second while you do that. Here we go. Domain. Everything works except what? It's kind of the way I like to start. And looks like 0 and 5 are both going to cause problems. 0, 5, can't be those two, can be everything else. Raise your hand if you had the right domain. All right, good. Then on to verticals. The verticals are coming from this. And they're either, everything down there that causes the problem is either making a vertical asymptote or it's causing a hole. And there's no holes because there's nothing on top to cancel things on the bottom, and therefore there is none when it comes to the holes. So therefore both those things, x equals 0 and x equals 5, were vertical asymptotes. The horizontals are the ones Bob tells you about. Is this a Bob? It is bigger on the bottom, bigger degree on the bottom, and therefore it's like I like to say he's an outsider. It's what's outside the fraction that matters. Again, if there had been a like plus 5x out there, do you get that y equals 5x would have been the slant asymptote? If there's just a number like plus 6 out there, then the asymptote's y equals 6, and that's a straight line asymptote. Okay, but since there's nothing out there, I could say there's a plus 0, and therefore it's y equals 0 out there for your horizontal asymptotes. Okay. Raise your hand if you had that right. Good, then sketch it. Make me a sketch of what this thing should look like. don't you keep doing it at your seat in here? Test it and see if it works. All right, here we go. Did you have an asymptote here, an asymptote here, an asymptote here, and then it's probably like the other one where you go like this, and maybe it's like this. I don't know. How am I supposed to know? Test some points. Like, give me a point to test, and don't say like 5. 4.9. Okay. So I can see if 4.9 will tell me whether or not I should really go up right there. So I put in a 4.9 and a 4.9, and that's going to mean I have about negative 0.1 times 4.9 is negative 0.49 on the bottom. And there's a negative 4 on top. The negatives cancel. I get a positive number. If I get a positive number, and it happens to be about positive 8, I know it's heading up right here, and so yay, I was right there. Did it turn out that that was the right sketch for it? Oh, I'm hearing some disagreement. Okay, so did this middle thing end up making a parabola? Was it up on this side? How do you test? Just a slightly bigger than 0 then, right? Like 0.1. If you stick in 0.1, let's see what happens. I put in a 0.1 and a 0.1. Be careful, I didn't mean negative, I just mean 0.1. So this is negative 4.9, and this is 0.1, which moves the decimal over. That's negative 0.49 again, and this is negative 4. It's the same as last time. It's positive 8 again about. So it does go up like this. And then how do I know where it makes its turn? I would assume it touches right on this line here, but I don't know for sure. What could I do to find it? Let's try it. How about like 2.5? Wouldn't you kind of assume it would be right in the middle? Right between 0 and 5? My guess is that's at 2.5, but I'm going to find out. 2.5 minus 5 is negative 2.5. And then times that by 2.5. That's about negative 5-ish. And that's negative 4 divided by about negative 5-ish is a small positive number. Ooh, it didn't touch exactly there. So it was still positive. So maybe it does this. It gets close, but doesn't actually touch. All right, good enough. We aren't going to ask you to find every single point on this thing. Yes? Do you think there was a mistake? You think this one right here is wrong? Okay, let me test it. Did you test it? Cool. Did you try something bigger than 5 then, like 6? All right, so if I put in a 6 right here, 6 plus, or 6 minus, actually something really close to that would probably be even better, but I'm going to say about 5.1. There we go. So then this makes positive 0.1. This makes 5.1. 5.1 times 0.1 is 0.51. No, it's positive. So therefore it's negative. Holy cow. That one is a negative number, not a positive number. So when we go just past this line, I got a negative. Therefore, it must be doing this kind of a deal. And then was this one in the right spot? Okay, good. Do you get that you can't just trust that you kind of know what it looks like? You really don't know what it looks like. You might have an idea that's got like curves, but you don't know whether they're up above, like in here, or they're down in there until you test. I knew that I didn't know, but I thought maybe this is what it looks like. But you're totally guessing if you just make it copy all the other ones that you've done. Okay, so this is the overall tips that they give. So this is the testing values things. Determine the sign and write that sign above the interval. Okay, I think that the way I just showed you is the best way. And this is more steps if you needed them written out, step by step. And what they're saying is it's going to be positive in here, it's going to be negative in here, it's going to be positive in here, and it's going to be negative in here. And then once you know that, you can kind of draw all of your curves accordingly. But I was showing you how to do it where if you use like a decimal, you know that it's a really big number that's positive, or a really small number that's positive. And I think my way of showing that I showed you is probably the best. All right, so I think we should move to the exercises. Here is homework, and I did say we were going to grade homework today. So we are going to assign you a few, and then we're going to stop and grade homework. Here we go. Here we go. We are doing number 1 and 4 and 6 and 9. We're skipping unlucky 13. And 15 is an optional one because it says a challenger. And I think this is more intense than we need to be. So I'm going to just ask you to do one more thing, and that's this problem 3A. All right. One, 4, 6, 9, 15, and the AP problem number 3. I don't want to say it again. Sorry. All right. So we are now going to stop and grade homework from last